Hi, welcome to Lab Activity 5, thevenin equivalent. This is the lab outline. In part A, you will draw the circuit on multisim. You will make the simulations. First, you will draw the old circuit, our usual circuit, with 5 resistors and 1 voltage source. And then, in this circuit, we will consider the point A and B, these points, A and B, and we will make a thevenin equivalent for that circuit. In the second part, you will draw this circuit, and you will reject the 1.5 kilo ohm resistor, and you will look at the open circuit voltage between A and B. And here, look, I have inserted a potentiometer. It's because to see the exact 3 volts, okay? If you don't use this, you cannot see exact 3 volts. You will put a potentiometer here and adjust it to see exact 3 volts. And here we have measured the thevenin voltage. Actually, we have adjusted it to 3 volts. And then we will measure the thevenin resistance. For that purpose, we have made the voltage source 0 volts, so it's equal to a short circuit. And then, without changing the value of potentiometer, it should be 40,000, okay? Yes, in the same circuit, without changing the value of potentiometer, you will read you will simulate the thevenin resistance between A and B, and you will see 5.3 approximately kilo ohms. And the voltage, thevenin voltage was 3 volts, and the thevenin resistance is 5.3 kilo ohms approximately. And then, using theoretical values or thevenin reduction methods, you will calculate. We have calculated 3 volts and 5.333 kilo ohms. And in real circuits, we cannot find the exact values, but we can find the approximate values, approximate value components. And we will use a 3 volt voltage source. I will use 2 1.5 batteries connected in series. And you will draw this equivalent. Because you don't have actually 5.3 kilo ohm resistors, you will use in real circuits this serial combination of 3.3 plus 2 kilo ohms. And of course, in simulation, you will directly simulate 5.3 kilo ohms. Or instead, you can use a potentiometer, and it's 10 kilo ohm potentiometer. If you adjust it 53%, it will be 5.3 kilo ohms. And this will be the thevenin resistance. This is the thevenin voltage. The thevenin voltage that you will read between points A and B is 3 volts, and the thevenin resistance that you will read from the thevenin equivalent circuit is 5.3. You can use, again, I'm repeating it, you can use 2 resistors connected in series, or you can use a unique resistor 5.3 kilo ohms, or you can use a potentiometer like this. Okay, here I'm reading the thevenin resistance of the circuit. Look, I have cancelled the voltage source, and I have assumed it is 0 volts connected like this, and the total resistance between A and B is 5.3 kilo ohm. And then I will insert a 1 kilo ohm resistor between point A and B, and I will read the voltage. Then this is my actual circuit. This is the thevenin equivalent. I will put 1 kilo ohm resistor to the thevenin equivalent, and I will read another value, and I will see that in the simulation I have to see that these 2 values are unique, same. Okay, they are approximately same. And then I have changed the resistor. Now I have inserted a 10 kilo ohm resistor here. I will read another value, and this is my actual circuit, and this is the thevenin equivalent circuit. I have inserted a 10 kilo ohm resistance, and I should read an approximate value, okay, very closer value to the actual circuit. And now let's construct the circuits, our circuits, in part B. This is our circuit. I will use a potentiometer, 1 kilo ohm potentiometer, to adjust the voltage, open circuit voltage between A and B. to make it 3 volts exactly. And for the Thevenin equivalent circuit, I will use a 10 kilo ohm potentiometer, and I will adjust this resistance. Look, this is my circuit, okay, this is my previous circuit, KVL KCL circuit, and I will put a potentiometer here. This is the switch, okay. I will make it unplug, and I will put a potentiometer there. So now I have completed my circuit, this circuit, okay. The old one, there was a switch here, and I have replaced the switch with a potentiometer. Now I have the same circuit, okay. This is the same circuit of this. And then I should remove 1.5 kilo ohm resistor. Look, this is 1.5 kilo ohm resistor. I'm removing it, okay. And now this is point A, and here is point B. This is point A, and here is point B. And look, this is the Thevenin equivalent circuit of my circuit. Okay, this is the Thevenin equivalent of my circuit. And I have used 2 batteries. Okay, each of them is 1.5 kilo ohms, and I have connected them in series, so I have 3 volts. And this is a switch to make the circuit on and off, and this is a potentiometer, 10 kilo ohm potentiometer. I will adjust it to the equivalent resistance, Thevenin resistance. And it says, show your work, show your teaching assistant how to measure open circuit voltages and currents and compare the values whether they are reasonable or not. Adjust the potentiometer to see the same open circuit voltage. Okay, let's measure the values. This is my multimeter. I'm adjusting it to read voltage. Okay, now it's adjusted to read DC voltage, and the probes are connected properly. Black is connected to COM port, and red is to voltage reading. And now I will read voltages. Look, this is my usual circuit. I will read the voltage A and B, and I will assume this point is A is positive and this point B is negative. So I'm reading the open circuit voltage. Look, and as I'm not reading exact 3 volts, so I will change the potentiometer's value to read the exact values. Okay, I will change the potentiometer, I will adjust it to read exact 3 volts. Look, I am changing it, and the voltage should change. Okay, as you see, voltage is decreasing between point A and B, and I'm changing in the reverse direction. I should read higher voltage. Okay, it's very closer to 3. Now it's okay. Okay, you can assume it's just 3 volts. Now I'm reading 3 volts, and in my Thevenin equivalent circuits, I should read 3 volts again. This is positive side, this is negative side. Can I read 3 volts? No. Why? The switch is off. I'm making it on, and I'm reading approximately 3.1. So I can increase the other circuit's voltage. Okay, let me increase it to 3.1. Okay, let me increase it. So now I am exactly reading the same values. Okay, 3.1. And then I will read the Thevenin resistance of these 2 circuits. Now I have read the open circuit voltages, and then I will read the thevenin resistance between point A and B. So I should make the voltage source off. Yes, now I have removed the power connections. Okay, look, I have removed them, and I have inserted a short circuit for the voltage source. Okay, I have made this connection. Look, I have removed this voltage source, and I have make it short circuit. Okay, I have connected a point with a short circuit between this point and this point, and I will measure the open circuit resistance. So I have constructed the circuits, and I will measure the resistances between the point A and B. Look at the circuits. I'm adjusting my multimeter to the ohm meter mode, and now I'm measuring the resistance, and the resistance that I read is 5.3 kilo ohms. Okay, approximately 5.3 for my actual circuit. And to construct my circuit, thevenin circuit, I have to adjust the resistance to the same value. Now I'm reading the resistance between A and B, and now what I'm seeing is 6.9. So I have to adjust my potentiometer. Okay, let's adjust it with a screwdriver, and I have to read 5.3. Okay, I'm changing the value. Look, I'm changing the value. I have to read 5.3 kilo ohms. Okay, now I'm reading 5.3 approximately. Okay, 5.3. That's it. So I have the same thevenin voltage for that circuit. Okay, I have the same voltage, I have the same resistance. So this thevenin circuit will be equal to my actual circuit. Now I can test. I will replace different voltage, different resistors between points A and B in both circuits. Okay, and I will see the same values. Before that, I have to connect the power connections first. Yes, these are my two circuits. This is the actual circuit. This is point A, this is point B, and this is the thevenin equivalent. This is point A and point B. I will connect different resistors. For example, let me connect a 1 kilo ohm resistance and see what happens. Are they equal or not? I have inserted 1 kilo ohm to my actual circuit, and I'm inserting a 1 kilo ohm resistors to my thevenin equivalent circuit. And let's read the voltages. Are they equal or not? Let's read. Look, I have to touch the red side to the positive, to A point, and this is to B. And what you see is (0.5 approximately. Okay, this is my actual circuit. And let's touch it to the thevenin equivalent circuit. Okay, it's touching to thevenin equivalent circuit. And now I'm reading approximately 0.5 volts again. Okay, they're approximately same. So it works. But let's change the resistors with 10 kilo ohm. What happens? And see then. I'm inserting a 10 kilo ohm resistor to my actual circuit, and then I'm inserting a 10 kilo ohm resistor to the thevenin equivalent circuit. And let's read the voltages. In actual circuit, voltage will be approximately 2 volts, okay? And in my Thevenin equivalent circuit, what is this? Look, again, it's approximately 2 volts. So my Thevenin equivalent circuit works, okay? It holds for different situations. It has the same open circuit voltage, open circuit resistance. It has the same response for 1 kilo ohm, same responses for 10 kilo ohm resistors, okay? So they work identical. They have the same properties. So I can use this Thevenin equivalent circuit for this guy, okay?